With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given that there is a cylinder closed at both ends is separated into two parts 45 centimeter each by a piston impermeable to heat. Impermeable to heat means heat cannot cross the piston. Now both the part contain the same masses of gases at a temperature of 30 Kelvin and pressure 1 atmosphere. Now if the gas in one of the part is heated such that piston shift by 5 centimeter, then the temperature and the pressure temperature and the pressure of the gas in this part after heating. Okay, so we just draw our this cylinder. Let's say this is our cylinder. Okay, now initially what is happening? Initially this is divided into two equal parts, and equal parts they are having a volume. So here volume would be, so this is this length is given as to be 45. So our volume for this part would be 45 times the cross sectional area. Now pressure is 1 atmosphere and temperature is 300 Kelvin. Here also volume would be 45 into area, and then this pressure is 1 atmospheric pressure, temperature would be 300 Kelvin. Now while we have transferred the heat and the mass is also the same. Now mass is same, we can say that moles would be same. So if n moles are here, then n moles would be here. Okay, now what we are doing, we are just heating. For example, this part we are heating, so we just draw the second situation. Now in the second situation, so the total volume would remain same. Okay, we are just shifting this. Let's say we have given heat to this part, so this part would expand and this would compress. Okay, now this shift is basically 5. This shift is 5 centimeter. Okay, so what would be the new volume for this part? New volume for this part would be 45 was initially, 45A was initially. Now there is 5 centimeter of expansion, so this part would become 50A. Okay, this would be the volume, and this would be reduced by 5, so it would be volume would be equals to 45 minus 5, that means 40A multiplied by the cross sectional area. Now at this portion they are at this portion they are coming to rest. That means the pressure in this chamber would be same as the pressure in this chamber. We can say that pressure in this chamber. So we just denote these condition as to be our 1. I.e. we just say that these condition, the pressure here, the temperature and the volume here, we just represent it by 1I, and these condition by 2I, and here the condition would be represented as 1F, and the here condition would be represented at 2F. So I means initial and F means final. 1 means the first chamber, 2 means the second chamber. So we can say that here the pressure P1F would be same as the pressure P2F. Why? Because we can see that they are finally coming into equilibrium, so the pressure should be same. So we can say that our P1F would be equals to P2F, P1F would be equals to P2F. Now using ideal gas equation, we know that PV equals to nRT, or we can say that our P would be equals to nRT divided by V. So if we use for the first case, so the number of moles is N, universal gas constant is R. What is the temperature here? We don't know, so we just say that it would be equals to T1F divided by, we need to divide it by volume. Volume is 50 times A. This would be equals to P2F. Now here number of moles would be N, universal gas constant is R. What would be the temperature here? Since this chamber is impermeable to heat, the piston is impermeable to heat, that means the heat which is coming here cannot penetrate here. So the temperature would remain same because it is not getting any heat. So the temperature would remain same, it would be 300 divided by volume. Volume is what? 40A. Okay, so the only unknown in this is T1F, and if we solve this, then our T1F would turn out to be, which we need to find, it would turn out to be 375 Kelvin. This would be our temperature. Okay, now also we need to calculate what is the value of the pressure. Okay, now pressure, using the same ideal gas, we can say that this P1 V1 equals to nR T1 in the initial condition. Okay, now P1 V1 would be equals to nR T1 in the final condition. Okay, using ideal gas equation, this is simply the ideal gas equation. Now if we divide these two expressions, then we get the value as P1I, then V1I. Now nR would be cancelled, so it would be T1I divided by P1F V1F T1F. Okay, Now, what is the initial pressure? Initial pressure is 1 atmosphere. We put the value as 1. Initial volume is 45 A divided by P1F, final pressure of 1, we don't know. What is the this final volume of 1? It was 50 A. What is the initial temperature? It is 300. And what is the final temperature which we have calculated? It is 375. We just checked the value of the volume. So it is 45 and 50, correct. Okay, now if we calculate this, then our final pressure for the chamber 1 would turn out to be 1.125 atmosphere. Okay, this would be the final pressure in terms of atmosphere. Now we can note that even though the area we were not knowing, even though we were not knowing the volume, but if you multiply with the area, so we can get this area would be cancelling from our expression. Okay, and here also we have put the this pressure in terms of just atmosphere. Why? Because finally the pressure would be, we can just put the unit of pressure as in terms of atmosphere. So which option is the correct option? The correct option would be our D option, temperature 375 and pressure 1.125 atmosphere. Hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.